Sea surface temperature, or SST, plays a crucial role in the development and intensification of typhoons or hurricanes and cyclones, depending on the region. Warm ocean water provides the energy these storms need to form and grow. Here's a detailed explanation of how it works.
This is presented to you by Education 4708. Just proceed to view the full content.
Disclaimer. The content on this channel is meant only to provide helpful insights, tips, and information on certain subject or topic. While we strive to provide accurate and up-to-date knowledge, this is not a substitute for professional advice. Always consult a qualified expert or professional for your specific needs. We encourage you to use this content as a guide for learning and additional information. If you think this does not fit what you want, please skip the video.
Sea surface temperature, or SST, plays a crucial role in the development and intensification of typhoons or hurricanes and cyclones, depending on the region. Warm ocean water provides the energy these storms need to form and grow. Here's a detailed explanation of how it works. Warm water as a fuel source. Typhoons are fueled by warm, moist air, which typically forms over oceans with SSTs of at least 26.5 degrees Celsius or 79.7 degrees Fahrenheit. Warmer water increases the evaporation rate, adding more moisture to the air directly above the ocean's surface. As seawater warms, it heats the air above it, causing this air to become warmer and lighter, which encourages it to rise. This rising warm air is a critical step in the formation of a typhoon. Evaporation and humidity. Evaporation occurs more readily over warm water, which means higher SSTs lead to more water vapor in the air. This moisture-rich air rises into the atmosphere, carrying potential energy with it in the form of latent heat. When the warm, moist air rises, it cools and condenses, forming clouds. This process releases latent heat into the atmosphere. This heat warms the surrounding air, causing it to rise further and drawing in more warm, moist air from below, creating a self-sustaining cycle. Low pressure formation. As the warm, moist air rises, it creates a low-pressure system near the ocean's surface. Air from surrounding high-pressure areas moves in to fill this low-pressure zone, creating strong surface winds. With continued evaporation and condensation, the storm system grows and the low-pressure area deepens, causing winds to strengthen further. As the warm air rises and winds increase, the Coriolis effect caused by Earth's rotation begins to act on the air, moving toward the low-pressure center. This deflects the wind, causing it to spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere, giving the storm a cyclonic shape. This rotation is a signature feature of typhoons, helping to organize the storm and intensify the low-pressure system. The rising air cools and forms a ring of thunderstorms around the storm's center, called the eye wall. This region experiences the strongest winds and heaviest rainfall. As the storm intensifies, the air in the center sinks slightly, forming the eye where winds are relatively calm. The eye wall acts as a barrier, trapping warm, moist air in the storm and further fueling it with energy. Positive feedback loop. Warm sea surface temperatures continuously fuel this cycle by providing more moisture and energy. As long as the storm remains over warm water, it can continue to grow in strength. The rising air, condensation, and release of latent heat feed back into the system, making the typhoon stronger. When sea surface temperatures are especially high, such as during events like El Niño, typhoons can become unusually intense and long-lasting. Weakening when moving over cooler waters or land. Once a typhoon moves over cooler waters or land, it loses its fuel source of warm water and moisture, leading to weakening. Land causes a drop in humidity and increases friction, disrupting the storm's structure. Why warm SSTs are key to typhoon strength. Warm sea surface temperatures don't just promote typhoon formation, but also dictate their intensity. Warmer waters can lead to more intense typhoons with higher wind speeds, heavier rainfall, and greater potential for destruction. This is why typhoon season typically aligns with periods of warmer sea surface temperatures, when oceans have stored up enough heat to support these powerful storms. In summary, warm sea surface temperatures provide the heat and moisture necessary for the formation and growth of typhoons. This process involves complex feedback loops, driven by rising warm air, condensation, and the Coriolis effect, all working together to form the intense spinning storms known as typhoons.